Alright, so next I have an example here. I've got two vectors, v and w, where I actually give you the components. And then I have a list of things to find. So here I have, we're going to find 2v minus w, just the algebraic representation. Magnitude of v, magnitude of w, the magnitude of v plus w. The angle for v, the angle for w, so the angle for v I'll call alpha, the angle for w I'll call beta, and then the dot product of the two. So it covers a lot of the different things that we've looked at so far. So first thing is the 2v minus w. All I'm going to do is I'm going to double the coordinates of v and then subtract the coordinates of w. Okay, so 2v minus w, if I double the coordinates of v, I get 4 and negative 6, and then subtract off the coordinates of w. Okay, and again we subtract these component by component. So we would get 4 minus negative 1. The double negative makes a plus or a positive, so it would be 4 plus 1 is 5. And then negative 6 minus 4 will give me a negative 10. Okay, so 5 comma negative 10 is that difference. Okay, that's a new vector essentially. And it's found by taking two vector v's and subtracting a vector w. Now let's look at the magnitude of v. Well, that's the square root of the square of the component, so it would be 2 squared plus negative 3 squared. 2 squared is 4. Negative 3 squared is 9. 4 plus 9 is 13, so we get the square root of 13. That's our magnitude. If we look at the square root of w, the magnitude of w, we end up with the square root of the sum of the squares of its components, which are negative 1 squared and 4 squared. Negative 1 squared is 1. 4 squared is 16. 1 and 16 makes 17, so this is the square root of 17 on that one. Okay, so we got square root of 13 for the first one, square root of 17 for the second one. Now I need the magnitude of v plus w. Well, to do that, there's a couple different ways. I could do this geometrically, like we did in the past, where we look at the parallelogram, we've got to look at angles and stuff like that, but really it's a lot easier just to go by component. So what I'm going to do is I'm going to figure out what v plus w is as its own vector, and then just use the Pythagorean theorem. So as its own vector, if I add these 2 plus negative 1, you get 1, and negative 3 plus 4 is also 1. So the sum of the two vectors is 1, 1. And then if I look at the magnitude of v plus w, it's the square root of the sum of the squares of 1, 1. Well, it's 1 squared plus 1 squared, which is square root of 2. Okay, so the magnitude of the sum is the square root of 2. Okay, so that gives me everything off of the first line there. Now we've got to look at these angles. For these angles, we could use the sine, the cosine, or the tangent formulas. In fact, in this case, I would probably go ahead, I guess it doesn't matter because I have my root, or my magnitudes in here. I could really use any of them. But I think I'm going to go ahead and use the tangent formula. Get rid of some of these. I don't really need this now. So I know that the tangent of alpha being the angle for v, is just going to be the y value, the y component divided by the x component. So it would be negative 3 over 2. So how do I find alpha? Well, using the inverse tangent, right? Alpha would be the inverse tangent of negative 3/2. If I go to my calculator on this, I'm going to keep this in degree mode. We'll put these in degrees. It's going to be an angle. And let's make sure I'm in degree mode. I am. So I'm going to go inverse tangent of negative 3/2. And of course, it's going to be something I need to round off anyway. It's going to be negative 56.3 3 approximately. But let's hold off right there for a moment. Remember, inverse trig functions have a very specified range to them. Only certain quadrants show up. This negative 56 degree angle is a fourth quadrant angle. Well, if you think about where this vector is, if you go 2 over, 3 down, oh, that's a fourth quadrant angle. That's what we want. It's not always going to be the case. If we ended up in the second or third quadrants, we'd have to convert this angle to another angle. Now, it's also the case that I may not want, well, I guess it's fine. So alpha is a negative 56.3 degree angle. It's going down into the fourth quadrant. Okay. Okay, so let's take a look at beta now. We know that the tangent of beta is y divided by x, so it would be 4 over negative 1, which of course is your opposite over adjacent sides. Well, 4 over negative 1 is negative 4, and of course then beta, the angle, is the inverse tangent of negative 4. Again, I'm going to punch that in here. Inverse tan, negative 4, and I get about a negative 75. It rounds actually to about 76.0. So approximately negative 76.0 degree angle. I should put degrees on those. Okay. If I round that to the nearest tenth. So it's 75.963, something like that. Keeps going. So anyway, so that's beta. Now think about this. This angle, or this vector, the angle is in, again, the fourth quadrant. But the vector is negative 1 in the x, 4 in the y. That's a second quadrant angle, not a fourth quadrant angle. So I don't want this. Instead, right, so this vector is negative 1 comma 4. It's going that way into the second quadrant. But this angle is reading down here. So how do I convert it to the actual angle beta? Well, I need to add 180 degrees to it to get it over into that second quadrant. So if I add 180 to that angle, I'm going to get 104 degrees. So that's a 104 degree angle. So beta is really approximately 104.0 degrees. All right, that's going to be the actual angle for beta. Now finally, the last part of this is to do the dot product. So V dot W is, again, remember with the dot product you just multiply the components together, corresponding components, and add those products. So it's 2 times negative 1 plus negative 3 times 4. Okay, so the product of the x's, the product of the y's, and add them together. So it would be negative 2 minus 12 would be a negative 14. So the dot product here is a negative 14. Again, a dot product is always going to yield a constant or a scalar result. Okay, so that gives us kind of a good overview of just the technical calculation of each of these different quantities.